Let us learn something more about inequalities. Let us consider the following situations. The first situation is Siddharth goes to market with rupees 200 to buy rice, which are available in packets of 1 kg. The price of one packet of rice is rupees 30. If X denotes the number of packets of rice which he buys, then the total amount spent by him is rupees 30x. Since he has to buy rice in packets only, he may not be able to spend the entire amount of rupees 200. Why? Because 200 is not divisible by 30, hence 30x is less than 200. Let's call this statement 1. Clearly the statement 1 is not an equation, as it does not involve the sign of equality. Let's consider case 2. Chetan has rupees 120 and wants to buy some registers and pens. The cost of one register is rupees 40 and that of a pen is rupees 20. In this case, if X denotes the number of registers and Y the number of pens which he buys, then the total amount spent by him is rupees 40x plus 20y, and we have the inequation 40x plus 20y is less than or equal to 120. Since in this case the total amount spent may be up to rupees 120, note that the statement 2 consists of two statements. 40x plus 20y is less than 120. Let's call this statement 3. And 40x plus 20y equals to 120. Let's call this statement 4. Statement 3 is not an equation. That is, it is an inequality, while statement 4 is an equation. Definition 1. Two real numbers or two algebraic expressions related by the symbol less than, greater than, less than or equal to, or greater than or equal to form an inequality. 3 less than 5, 7 greater than 5 are the examples of numerical inequalities. X less than 5, y greater than 2, x greater than equal to 3, y less than equal to 4 are some examples of literal inequalities. 5 is greater than 3 and less than 7. X is greater than or equal to 3 and less than 5, and y greater than 2 and less than 4 are the examples of double inequalities. Some more examples of inequalities are ax plus b less than 0, ax plus b greater than 0, ax plus b less than equal to 0, ax plus b greater than equal to 0, ax plus by is less than c, ax plus by is greater than c, ax plus by is less than equal to c, ax plus by is greater than or equal to c, ax square plus bx plus c is less than equal to 0, ax square plus bx plus c is greater than 0. Let's call these statements statement number 5 to statement number 14. Inequalities 5, 6, 9, 10 and 14 are strict inequalities, while inequalities 7, 8, 11, 12 and 13 are slack inequalities. Inequalities from 5 to 8 are linear inequalities in one variable, x, when a is not equal to 0, while inequalities from 9 to 12 are linear inequalities in two variables, x and y, when a is not equal to 0 and b is not equal to 0. Inequalities 13 and 14 are not linear. In fact, these are quadratic inequalities in one variable x when a is not equal to 0. In this chapter, we shall confine ourselves to the study of linear inequalities in one and two variables only.